All right. So is there any question from the last lecture?
For me, no.
All right. So Taha and Muiz, you both are brothers, right?
Yes.
Right. Okay. Good, good. All right. So I think we'll wait 2 more minutes so that if there are more people, they can join in as well. We'll start at 3:05, I think. Also, I keep stressing in the group that don't be late, but some students are still late. Let's wait 2 more minutes maximum.
Okay.
I'll just write it over here for whoever joins in. All right, so everyone can hear me?
Yes. Yes.
Okay, great, great. So, yeah, is there any question from the last lecture or from anyone?
No.
All right, how about Minhal and Noshirwan? Is there any question from the last lecture? All right, so we left off at this thing. We were doing kinematics. We got a bit off topic. We discussed some of the things. And so, wow, it says your internet connection is unstable. You can hear me, right? I'm clearly audible for everyone.
Yes.
Yes, I can hear you.
Okay, good, good. All right, so let's start with this thing. We were discussing kinematics. We discussed that the difference between kinematics and dynamics, there are really two things that we consider in Newtonian mechanics, kinematics and dynamics. Kinematics deals with motion without any reference to the forces that produced the motion, while dynamics deals with the forces as well. Now, very quickly, we know what are scalars. Scalars are any type of quantity which just need a number to completely specify that quantity, while vector, you need a number and a direction as well to completely specify the quantity. So with that knowledge with us, we can discuss two such quantities, well, one for each. We have something that is known as distance. Now, distance is really just a number. So for example, you have a particle and this particle travels any path, right? It takes any path. So it can be any path. That's why I'm drawing it like this, a bit curvy. And suppose it reaches to this point. Now, every the length of this entire path, this very weird zigzag or whatever type of line, the length of this line is the distance traveled, right? That's the total distance traveled. At this point, we do not care about the direction. So it's just a number, which means that distance is just the length of the path that the particle travels. We can also consider direction, and that's when we're talking about displacement. So these are just names given to quantities. So displacement is a number as well as a direction. So this means that you can define displacement in multiple ways. One of the definitions can be something like this, that it is the distance covered in a straight line, in a straight line. Now you can clearly see that direction is important over here. This meaning straight line, we are concerned with how the line should be, in what direction should the line be. So you can, this statement really says it all, but if you want, you can also specify it as in front, saying that in a specified direction. So for example, let's consider the same thing. This particle started from this point A and ended its journey at point B. Now, this was a very weird path that could have been taken to reach the point B. However, you could have just made your life very easy by just going directly from A to B like this. So I'll just use another color for that. I think that color is completely invisible. So let's just use. All right. Okay. So you can have done this thing for moving from point A to point B. Now, if you go directly on this path, which is a straight line from point A to point B, then that is your displacement, right? And the displacement vector, the displacement quantity is a vector like quantity. So for example, if I were on a circular path, so let's say I start my journey from this point, this is point A, and I travel in a circle and come back to this point A. So I start at point A, move in this circle and come back to point A, and then I stop. So what would be the distance covered if I was traveling on this circle of radius r? What would be the distance covered in this case? Anyone from the class? Specifically
It would be double the radius.
Well, almost right, but with a multiple of pi as well, right? So it would be 2 pi times the radius. It would be the circumference of the circle, right?
Yes.
Yeah. So I don't know how to spell circumference. I think it's something like this, whatever the spelling. Circumference of the circle of this radius r, which is given as 2 pi times the radius of the circle. And it is really 2 pi r. One way to think about it is because 2 pi is a complete rotation of 360 degrees. Because these quantities, they are in terms of radians, right? Now, radians is another way of measuring angle. At this point, you're not really concerned with that. But this 2 pi really comes from the fact that 360 degrees is 2 times pi in radians. Now, degrees is an angle, is a measurement, or it's a unit to measure angles. Similarly, radians is also a unit to measure angles. All right, so it's 2 pi r because the complete revolution over this circle is a 360 degree rotation, right? And that 360-degree rotation is represented in radians as 2 pi. So the circumference of the circle is 2 pi r. And so that was not the topic of physics, that was just mathematics. And so that's my distance. Everyone agrees with that, right?
Yes.
Okay, I cannot hear you. Can you
Yes,
repeat?
agree.
So, yeah, everyone agrees. Everyone agrees with this thing, that if I start my journey from point A, travel in a circle and come back to point A, the distance is the circumference of the circle, which is 2 pi r. What about displacement? Remember, you can also think of a displacement as the shortest path between these 2 points, right? So when we were studying displacement, we said that it is the distance traveled in a straight line in a specified direction. So if it's these 2 points, then it's this straight line between. Yeah.
There's no displacement because you are already on that spot from the first place, because the person is moving in a circle motion, so he will arrive at the same position.
Right, exactly. So you're starting your journey from point A and you're ending it again at point A. So it really means that if you were starting at point A and wherever you had to come back, you're coming back at the same point A. So it doesn't matter if I could call that another point as B, but point A and B lie on each other. So the distance between these two would be 0, right?
Yes.
So that's why the displacement vector is 0. One way of thinking about is this. The other way that you can physically understand why is it 0 is if you think in terms of vectors, because displacement is a vector. So if I draw a vector tangent to every point on this circle, so if this vector would look like this, you have to follow the path of the circle, right? If I draw it over here, it looks something like this. If I draw this vector over here, tangent to this point, it looks like this. I think I should use another color to draw these vectors. Just 1 second so that you can. All right, here. So, and at this point, if I draw, it would look something like this. And similarly, at this point, it looks like this. And you get the point. I'm sure you get the point, right? So it looks like this, and then it looks like this. So you can draw as many vectors as you like at every point on this circle. There are infinite points on this circle if you really think about it. Now, add all of these vectors together, because that's the path that you're taking, right? So if I take these vectors and I add all of them together, what should I get? What will I get?
Infinite, because they are infinite vectors.
But think about the directions of these vectors. For every vector that I have, which points in a particular direction, I also have a vector which points in the opposite direction. For every vector that I have, which is pointing in a direction, I have another vector which points in the opposite direction, which means that if I add all these vectors together, it would sum up to 0 or it would vanish, right?
Yes.
So is that clear? Right. So that's why the you can say that sum of all these vectors would be 0, because again, like I said, for every vector that points in a particular direction, we have another vector. We have a vector that points in opposite direction. So when you add these two type of vectors, you will get a 0. So because we have for every vector, that means that it would give in total, all the vectors would give you 0. So everyone understands this, right? Is there anyone who has a
Yes.
problem?
I don't get it.
Okay, Urva does not get it. Okay, so it's okay. Think in terms of these vectors, right? So I started my journey at this point A, right? And I have to travel on this circular path and come back to point A. Imagine yourself, you're traveling on a circular track and you're coming back to where you started. Now, in terms of vectors, because displacement is a vector quantity, which means that I can represent displacement as a vector, any vector which has a length and an arrowhead. Arrow points to the direction and the length tells you the magnitude or the length of the vector, how much of the displacement was there. So because that is the representation of displacement, I can, at every point on this circle, I can draw this displacement vector, which tells you that at this point, this displacement vector, when it starts, it would be very small. So I haven't drawn these vectors to the accurate size. But as soon as you start the journey from point A, you'll move some distance or displacement. And so there will be a very tiny vector over there. Then you will move more distance. There will be some vector over there, move more distance. So you're traveling in this circle and the direction of this vector always points to the direction of your displacement. So when you have all of these vectors on this circle, so if you look at this one, let me use this color. For this vector, we see that I have this vector. They both point in the opposite directions. So when I will add these two vectors together, it will sum up to 0. Similarly, if I look at this vector and I look at this one, these two are same, but they point in the opposite directions. So they will add up to 0. Similarly, this one and this one. So of course, the drawings are not completely accurate, but all of these vectors that I'm drawing, we can draw as many vectors as we like, but for every vector, there will be a vector which points in the opposite direction. And this is always true if you're starting your journey and ending your journey at a same point. So does that make sense now?
A little, I guess. I'll
Yes.
try to understand.
Yes.
All right, sorry. And how about you, Urva? Is it clear?
A little.
Okay, think about this. You can, you have to understand again that if I have a vector that points like this, and I add to this vector a vector that is like this, and it points in this directions. When I add these two vectors, if I'm saying that this vector means positive, and this means if it's in the opposite direction, it's negative. So we have this plus vector plus a minus vector. So it will be plus something and minus something, which will become 0, right? So it's like having a plus 1 and a minus 1. So it sums to 0. So it's the same thing that's happening over there, that for every vector, there is another vector which points in the opposite direction. Because think of our path. We started from A and we were moving like this. So we were moving here, then we moved here. So this is the direction, right? So I've just drawn these vectors according to the direction of the path that we are taking. So if you're traveling in a circle, you'll always be traveling in such a way where at first you start your journey. There will come a point when your journey will start moving in the opposite direction. Because, and this is always true. For example, think in terms of this. If I walk from, suppose you're in your room, you walk from your room to another room and you take a particular path and you come back to your room using the same path. So you have walked in a particular direction and then you have walked in the opposite direction. Now, if you add those two, that would be 0. So think in terms of that maybe. Is it slightly any more better?
100% clear.
Yes.
Okay. Okay. So it's okay. You can think about it after the class as well. And maybe if you understand it, well and good. If you don't, you can always ask again, right? It's not a problem. So that's displacement really. Now, I think we have spent too much time on displacement as well, distances and displacement. But I hope that the idea of why displacement becomes zero at a point, if you're starting and ending a journey at the same point, is zero. Now, with that, we can define something. Suppose that I have a particular distance, but it's not constant. Suppose your distance is changing. So that, what does that mean? That means that if I am at a point and I'm moving at this point, and then I'm moving at this point. So if I start from this point, of course, I've traveled zero distance. I move to this point. I have traveled some distance. Let's call it small d1. Then I move from this to this point, and I have traveled some more distance d2. Every point that lies on this line, there is a value for unique value for distance, right? So for example, maybe you moved 1 meter here, 2 meters, 3 meters, 4 meters, 5, 6, 7, 8, 9, 10. And at this point, maybe some 11 meters and so on. You get the point, right? So at every point on this line, there is a unique value for the distance that you have moved. So if I carry a stopwatch with me, I can see that how long does it take for me to cover a particular amount of distance on this line. That's where the idea of speed comes in. You can define a quantity saying that it is the time rate of change of distance. This just means that it is how much of the distance has changed in a given time. So for example, you time yourself. Yeah, exactly. So that's the expression that you can write this thing. This is writing it in English, but in physics, unless you can write something mathematically with the correct mathematics, you cannot say that it's true. So you should always back up your statements using some mathematics, and the mathematical translation to this is an expression for speed, which is distance covered or distance traveled divided by time taken, which just means physically, it just means that it is how much of the distance am I covering in a particular amount of time. So for example, I cover, so I start from here and my stopwatch is set to 0. Suppose I arrive at this point where the value for distance is, suppose it's 10 meters. So, and say now the stopwatch reads 5 seconds, right? So maybe the stopwatch says 5 seconds. This would mean that my speed is, how can I define my speed? Speed is how fast can I cover a said amount of distance. So I'll just use 10 meters and divide it by 5 seconds. I'll get a number which is 2, and then meters divided by seconds, because 5 ones are 5, 5 twos are 10, and then we're left with meters divided by seconds. So we'll just write that down. And so this number really says that I can cover 2 meters for every second that passes on this clock. So 1 second passes and I'll cover 2 meters. Another second pass, I'll cover in total 4 meters, right? So in 1 second, 2 meters, 2 seconds, another 2 meters, which would be in total 4 meters. So that's physically what speed is, right? So, and you can write its units as meters per seconds, and these units are derived from the units of distance and time. Remember, distance and time, these were the base quantities, if you remember from the very first topic. And the units that are derived are meter per second, which are the derived units for speed. So is that clear? Is the idea of speed clear to everyone?
Yes. Yes.
Yes.
Okay, great, wonderful. So this was where we did not care if I'm moving to the right or to the left. I don't care about that at this point. I just care about I have to move. I don't care if I'm moving left or right. Okay. Now, suppose you care about that. You care about whether you're moving to the left or you're moving to the right, or in general, you care about the direction of travel. So in that case, you can talk in terms of displacement, right? And you can see how does the displacement change with time. So it's the same thing, time rate of change of displacement this time. And when you look at how fast the displacement changes, which means you are also concerned with how fast the direction changes. That's when you're talking about something that is called a velocity. So velocity is defined as the time rate of change of displacement. So everything remains the same, everything that we discussed in this part, except for the fact now you care about the fact that you're moving in what direction. So maybe you could start from here, and maybe the same thing you could have moved in this direction. So if this is my starting point, you always have to set a reference point, which is in this case a starting point. And at reference, we always assign a value 0. Now, if I move, you can, now it doesn't matter. You can say if I move to the right, that's positive, and move to the left, that's negative. Or you could say the opposite. It doesn't matter. You could have said that if I move to the right, then that's negative, and move to the left, then that's positive. But whatever of these two that you choose, either this or this one, you have to stick with one of them and use that throughout the entire calculation. So there is nothing special about that right is positive and left is negative. So that's something you should know at this stage. I'm telling you some things that are, you might feel like we're spending too much time on these things, but it's better that you understand these things at this stage, so that when you're studying, of course, you'll be doing A levels or so on. So these things will make more sense at that time as well. So you should completely understand the conceptual part of what we're doing. So that's my goal, basically. We'll try, of course, not try, but we will be completing the course timely. But sometimes it's interesting to think about things more deeply. Anyways, so that's this thing. Now, if you care about if you're moving to the left, then you can distinguish or differentiate between the two by using signatures. Positive for right and negative for the left. Again, these are not special. You could have assigned it the other way around as well. So in that case, what we are talking about is velocity. How fast is the displacement changing? So if I care that whether I'm moving to the right or to the left, then we are talking about velocity. How fast is that displacement changing? And the rest is the same. So velocity, mathematically, it would be defined as displacement covered per unit time. So is that clear for everyone?
Yes.
Okay. So
how are speed and velocity interlinked? Like, are they
oh,
interlinked in any way?
okay. Right. So I'll write. Yeah. So they're linked in this way that speed is just the magnitude. Sorry, it's just the magnitude of velocity. I'll explain what I mean. Right. So when I say when I put these two lines, it means I'm really getting rid of the direction. These two lines on any quantity, putting any quantity, I'll represent Q means quantity. So if I put these two lines to this, it means that I'm getting rid of direction. So that's the link between the two. So speed is just velocity, but without direction. So for example, you have a man and he's running, suppose man or woman, and he or she is running, and you don't care at this point, or let's say at start you say that he's running to the right with plus 10 meters per second. Wow, that's actually a very fast speed. But anyways, for a man, but suppose that I don't want this information. I don't care if he's running to the right or to the left. Then I'll just get rid of the direction, which means that I'll get rid of the sign, and I can say that he's running at 10 meters per second. I don't care if he's running to the right or to the left. You could have done the same thing with if he's running to the left. Maybe you would say he's running to the left. Now it's minus 10 meters per second, because left is, now we are saying that left is associated with a negative sign. Then this is the velocity, but the speed would be absolute of minus 10 meters per second. This absolute would get rid of the direction, which means it would get rid of this negative sign, because the negative sign is telling you that he's moving to the left. So we'll get rid of this negative sign, 10 meters per second. So that's the speed. So this is not telling you anything about the direction of this person. So if we remove the element of direction from velocity, then we get speed. The number is still the same, as you can see, but the direction element is eliminated.
I understand.
So, all right. Okay, so Urva, is that clear?
Yes, completely.
Okay, great. Perfect. Okay, so that's this. And now let's. Okay, so that's speed and velocity. Now we can do some examples as well, but I think those would be pretty straightforward. Let's try to do an example, and I'll ask you to tell me what the solution really to the example. What do you think? So let's do it in that way. Let me just do this side. Okay, so now suppose that you have a train. So this is just a question. Suppose you have a train and it travels in a circular track. So it starts from this point and ends back at this point. We can call this point anything. Let's just call it O. And there's a train that is traveling in this circular track, or a circuit of a circular track. And the circumference of this circular track is 2.4 meters. And we say that this train starts its journey at point O and ends its journey at point O. And the time that it takes to complete its journey is 4.8 seconds. So first, let's try to compute the speed. And then we'll try to compute the velocity. So what would be the speed? So let's say I want to compute the speed. It's a very quick problem, one-step problem for each part. So what would be the speed for this train that's moving in this way? You can understand that the distance that it would be covering is the circumference of the circle, right? Because it's moving on the circumference of the circle. We have a train that is moving on this circle. So what would be the speed in this case?
Would it be like
It's very
2.4 divided by 4.8?
Yeah, exactly. So that would be
0.5.
Exactly. So that would be 0.5 meters per second. And we got this by dividing the circumference by time. And the reason we did that was because the distance that the train would cover entire on this course is the circumference of the circle, and it covers it in 4.8 seconds. So just finding the ratio of the two will give you speed. What would be the velocity? That's the interesting part. Yeah, are you saying something?
velocity could be like this. 0.5 meters per second from the right hand side of the circle to the left hand side of the circle.
Sorry, I cannot hear you properly. Can you come closer to the mic?
Velocity is like this: 0.5 meter per second to the right hand side of the circle to the left hand side, or it can be opposite as well.
Okay, I did not really quite get you, but let me say this. Let me tell you the answer, and then I'll ask you the reason for that. So the velocity would be 0. Now, why do you think it's 0?
Because you're arriving at the same point.
Right, exactly. We're arriving at the same point, which means that velocity, which was displacement divided by time, but displacement is 0 because start and end point are same, which means that displacement would be 0, and so anything divided by 0 would be 0. Or you can again think in terms of those vectors that I drew, but I think that's getting confusing for people. So just whenever you start and end at the same point, the displacement vanishes, and so your velocity would be 0. So is that clear for everyone?
Yes, that actually did cross my mind, but I was unsure about the answer.
Okay, so at this point,